Hi everyone. Today I'm excited to talk to you about my computer vision final project, which is a small device I've taken to call in CatBeGone, an advanced solution for a primitive problem. Before we jump into the technical side, I do want to lay out what the problem is. And so, while the struggles associated with cohabitating with a cat have undoubtedly gone back to the earliest examples of feline domestication in 7,500 BCE, I was not really made aware of them until about 7 months ago when my boyfriend and I adopted a cat and named him Kodak. Hello. Hello. I should edit that out. Well, Kodak is the apple of my boyfriend's eye. I now know that I'm fully a dog person, and he's not really my favorite. I do, however, enjoy caring for plants, but Kodak has decided that it's his unalienable right to push my plants off counters, knock them over, or sit on them, which kills them, as you can see. And the only way that I found to curb that behavior is to spray him with some water, but I can only actually do that when I'm around. So what I'm teaching this little beautiful animal is that he can do whatever he wants, just as long as I can't see it. So what can I do? Obviously, the only solution is to hook up a camera and a servo motor to a Raspberry Pi, write a program that will sense motion, classify a moving object as Kodak or not using a fine-tuned ResNet 18 model, and then spray him should he get too close to the plants, obviously. And so that's the goal of our project today. In brief, this is kind of my setup or my approach to this. I wanted to make a really simple decision-making scheme that minimized the number of moving parts that I'd have to worry about. So if the camera looks for motion, if there's motion detected, is it consistent? If it is, let's identify what the object is. If that object is Kodak, then we track him as he moves around the frame. And if it's not, we just keep going. And then if he does enter like a spray zone or a critical area, we trigger the deterrent. So relatively simple, nothing like crazy complicated. And so the most difficult step of this whole project was actually training my object classifier to identify Kodak, as he is a standard issue gray-brown tabby. He's not very unique, but I did what I could. And so I gathered about 200 images of Kodak, as well as other random cats and dogs, including like friends' cats, just in case we would see them. And then with those images, I went through a data augmentation problem in which I introduced random noise as well as a saturation and brightness jitter to each example. And the reason you do this is to kind of increase the robustness of the model and make sure that it doesn't like break, because AI is notoriously affected by random jitters and things. After we did the training, I got an accuracy of 99%, which is really high, and that almost always means that my model is severely overfit, which is typically a problem. And it's most likely almost certainly due to the lack of original images in my training data set. If I wanted to fix this problem, I'd simply have to gather more images, but I don't really have time or interest. And since Kodak is the only animal in the house, I am comfortable leaving it alone for now. He just scratched the wall. I don't know. So moving forward into our motion sensing, with a classifier in place, I've implemented a motion sensing algorithm, as videos are simply stacks of images with the background should not change, especially if the camera is held still. So this actually was a really simple task. I simply captured the background images, converted it to grayscale and added a Gaussian blur. Then I subtracted the current frame from the background frame, which you can see in the top left here. Oh, dude, come on. Good job. I don't know what to do with him. Then if the difference between the background and the current frame is large enough, I use an OpenCV algorithm to pull out the most exterior contours of that difference to identify the outside boundaries of the object. and then the outer contours are used to draw a boundary box in red that you can see here. Cool. And then so once we've identified Kodak, or once we've identified a moving object, we then have to identify if it's him. And since Kodak is probably approaching the camera from the side, I wanted to make sure that his whole face was in the frame before identifying him. So I added a delay where if motion is sensed in 20 consecutive frames, then it'll send that object for identification using my CNN, the fine-tuned CNN. And if there's multiple identified objects, then each candidate box would be passed to the CNN. And here we can see this happen. And so what it does is it picks up the box when he enters the frame, and you'll see it track him in red. And then when it makes that change into the blue, that's the algorithm sending the captured red box to my CNN for identification. And then if it's positively ID'd, a template-based tracking system takes over. I had the box turn blue just so I know it happens. And then it follows his face around the screen. And then, now that we've had our positive ID and we're accurately tracking Kodak as he wanders around, it waits for Kodak to overlap with this kind of spray box right in the middle. And so if he does decide to go towards the plants and enter the spray zone, the servo motor is triggered to make one complete rotation, which pulls the string around the spray nozzle like trigger taut so that it triggers the bottle, and then he's met with a little refreshing blast of water. And if he doesn't enter the spray zone, then the algorithm just waits, and it can wait indefinitely. I'm hoping that by not punishing him immediately that he'll eventually learn not to make bad choices, but he's a cat, so my hopes are pretty low. Yeah, and then this is kind of the output of the whole system. Yeah, and so I thought this was a good example because you can see that there's multiple identified moving objects, and it's just because Kodak has a lot of stripes, which means that some areas look like there's a lot more motion than there actually is. But my program, I correctly identifies the box with his face, and then that takes over, and then when he enters here, you can see that the box goes away because he's triggered the system, and I don't want it to spray multiple times. So this is the spray bottle getting triggered. It does, and he is not a fan. Yeah. To improve this device, I would 100% add a case. As it stands, the electronics are open to the air, dust, cat fur, and anything else kind of floating around, which can cause huge problems. A case would improve the durability and make me feel as though it's less fragile, even if it still is. Further, I would try to fix the CNN issues with overfitting, and to do that, I would have my algorithm simply capture images of Kodak's face every time he interacts with it, and then save them so I could, without really trying, end up with another 500 images of Kodak. And I could also give it to friends who have cats or dogs, and do the same thing so that it's specific to my animal. That would fix the overfitting problem and make my model, and therefore the device, a little bit more generalizable. Cool. Well, thank you for your time and listening to my talk. I had a lot of fun making the device, and I'm happy to announce that 0 of my plants have been killed since it was implemented. Yeah, hope you have a great day.